So we have the ln of negative x minus 3. So remember, the ln is just y equals log base e of x, and we can switch that into an exponential, e to the y power equals x. We got negative 1, 0, 1 in for y, and then our x's are 1 over e, 1, and e. And again, remember, e is about 2.7. And we can plot those. And remember, e is a little bit more than 2.5. So there we go there. And your asymptote. And then this negative means that all the x's are going to become negative. So that is going to effectively flip our graph. So we're a negative e, 1 over e, negative 1. So about right there. And then negative 1, 0. And then negative 2, 1. Negative 2.7 and 1. There we go. And then we have to take this entire graph and then shift it down 3. So 1, 2, 3, 1, 2, 3, and then this one moves right about there. And here's our final graph. The green is the final graph. Our domain this time is a little bit weird because we flipped it over the y-axis. It's negative infinity to 0. Our range is negative infinity to infinity. And then our end behavior, the limit as x approaches, this time not infinity, but 0. From the negative end of f of x is, and we're getting smaller, so negative infinity. And then the limit as x approaches negative infinity, because this time we actually are going to negative infinity, of f of x equals infinity. We are going to be getting bigger. Here, your parent function, y equals the log base 4 of x. So it's 4 to the y power equals x. And we'll make our table. So we're 1/4, 1, and 4. We can plot those. And we're going to do a lot of things with this graph. Maybe I won't even bother plotting it. It might make life more confusing. Okay, so then this multiplies all the y's by 2. Remember here, we need to factor this. So this is actually this. And we're going to multiply all the x's, not by 2, but by 1/2. So this graph is actually going to get a lot skinnier. So 1/2 times 1/4 is 1/8. Then this is now 1/2, and this is now 2. So let's plot that one. Oops, this is negative 2 and 0 and 2. So we're at 1/8 and negative 2, which is very small, like right there. And then 1/2 and 0, so we're about right there. And then 2, 2. So there's our stretched graph. And then we have to shift. And again, you always want to do your shift off of the factored version of that inside part. So we're going to the left 1, and then we're going down 3. Moving to the left 1 moves our asymptote. And then left 1, down 3. So this one will be easy to move. Left 1, down 1, 2, 3. And then left 1, down 1, 2, 3. And then this one, left 1, down 1, 2, 3. So there's your final graph. Our domain this time is negative 1 to infinity. Our range is negative infinity to infinity. And our end behavior, the limit as x approaches infinity of f of x equals positive infinity, and the limit as x approaches the asymptote, which is negative 1 from the positive end, is negative infinity. These questions just ask you to find the asymptote. So hopefully after graphing all the logarithms, you'd realize that the asymptote always occurs at the shift, the horizontal shift for a logarithm, which is x equals 2. The exponentials, this next one, the shift, since it goes like this, and when you shift it up or down, that moves the asymptote. Your shift, your vertical shift, is always going to be your asymptote there, so negative 8. And then this one, again, I don't really care about this, I just want the asymptote, so it's y equals negative 1. And then we have this one, it doesn't shift left or right, so the asymptote is at x equals 0. In these, we just give you some characteristics of a graph, and you have to figure out what it is. It's best to try to make a sketch. So f of 1 equals 0, that means that we have the point 1, 0. The limit as x approaches 0, so that implies that 0 is the asymptote. Let's kind of draw that in. And as x approaches 0, it doesn't tell us which direction, but since this point is on this side of the asymptote, it makes me think that we're on this side. And it approaches negative infinity. And then as x approaches infinity, we get really big. So then we can calculate our domain. It would be 0 to infinity. Our range is negative infinity to infinity. And we just have to decide if this is increasing or decreasing, and it is increasing. So this next one, again, make sketch, negative 2, 0. The limit as x approaches negative 3, so that makes me think that I probably have an asymptote there, is negative infinity. And since this point is on this side of the graph, I'm probably also on this side of the graph. And then as x approaches infinity, I get bigger. So my domain this time is negative 3 to infinity. My range is negative infinity to infinity. And this graph is also increasing. It's generally getting bigger. And then this last one, we've got f of negative 1 equals 0. So we have that point. As x approaches 0, we get closer to negative infinity. So that makes me think that 0 is our asymptote. And as I approach, I'm getting closer to infinity. And then as x approaches negative infinity, I'm going to infinity, so I'm getting bigger that direction. So this time our domain is backwards. It's negative infinity to 0 with a round bracket, and then negative infinity to infinity. And then this graph is actually decreasing because it's generally going downhill.